the Panama Canal. Considered by many to be the eighth wonder of the world. It cuts through 50 miles of dense tropical jungle and solid rock, and provides a 10-hour shortcut between the Atlantic and Pacific Oceans, versus a treacherous 2-week passage around the tip of South America. Each year, thousands of ships go through the canal and are literally lifted across Panama's mountains by a remarkable series of water elevators and man-made lakes. When the canal was finished in 1914, it was a marvel of engineering, able to handle the mightiest ships of its day. But that time has passed. Today, new supercargo ships are double, even triple the size, putting Panama at a crossroads. Do they gamble billions on redesigning the canal for the 21st century? Or lose billions in revenue from all the ships the canal can't handle? The very future of that country could be riding on that decision. It's 6:30 in the morning at the Atlantic entrance to the Panama Canal. Senior pilot Dave Sherman is about to take control of a Russian-operated oil tanker. The Panama Canal is the only place in the world where a captain must surrender command of his vessel.
Tanker, where you guys at?
We're in the swell. We need a 9-meter rig, otherwise someone's going to get hurt.
After 25 years on the job, Dave still looks at every canal crossing as an adventure and knows he can never let down his guard.
Good morning.
Good morning.
How are you?
Welcome on board.
Thank you.
Yeah, please.
Navigating the canal is a high-pressure, highly skilled job from end to end.
Captain. Good morning. Dave Sherman. How are you?
Dave's now responsible for the ship and its cargo. In every lock, around every bend, danger lurks. Even the smallest mistake could be catastrophic. From the Atlantic side, Dave will have to navigate through 3 locks that will raise the tanker 85 feet to the level of Gatun Lake. At the other end of the lake, another set of locks will lower the ship back down to reach the Pacific. The locks are the key to the canal. But how do you pick up a giant cargo ship or oil tanker? Each lock consists of 3 separate but connected chambers. As the ship enters the first lock chamber, specially trained workers cast ropes to attach 1-inch thick steel cables to the bow and stern of the ship. These are connected to high-powered locomotives that ride along either side of the canal. These locomotives can tow 35 tons. That's like pulling 2 F-14 jet fighters. But it's going to take 6 locomotives to guide this 65,000-ton ship into the lock chamber. Dave slows the engines. It's here in the locks that his piloting skills first come into play. The Russian captain is nervous. His ship is 105 feet wide. Each lock chamber is 110 feet wide. That leaves only 2.5 feet of clearance on either side. By constantly adjusting the tension on the cables, the locomotives keep the ship centered in the lock chamber. Their movement must be perfectly synchronized to keep the cables taut. The doors close, holding back the ocean water. Up in the nearby control tower, operators turn the valves, releasing fresh water from Gatun Lake to raise Dave's ship.
Control house. Yes.
These are the same controls that were installed more than 90 years ago. Gravity pulls the water down from the lake and sends it into the lock chamber through 100 man-size holes in the floor. The rising water begins to lift the ship to the level of the next chamber. The water must fill evenly. Any turbulence could smash the ship against the sides, snapping the taut half-ton steel cables with enough force to slice a person in half. Once the ship has been raised, the locomotives climb to the next elevation. The 750-ton doors slowly swing open. The process is repeated until the ship has reached the level of the lake, 85 feet above the Atlantic. A ship of this size is considered a Panamax ship because it is the maximum size that can fit through the Panama Canal. When the canal first opened in 1914, the size of the locks in Panama actually set the standard for shipbuilders. Today, 13,000 ships per year transit the canal, carrying 190 million tons of cargo, generating almost $600 million in toll fees for the Panamanian government. But the Panama Canal has a problem. The world of commercial shipping is beginning to pass it by, literally. The new super cargo ships are too long and too wide to fit through the canal. But they are a sign of things to come. They are capable of carrying 3 times the cargo and are hundreds of feet longer and wider than the largest ships the canal can handle. Either the Panama Canal grows with the commercial shipping industry, or it will be left behind.
Next up on Extreme Engineering, how do you fit a 300-foot wide ship through a 100-foot wide canal?
These super ships are leading the container and bulk cargo business. Today, they make up 20% of the ships at sea. By the year 2020, that number will at least double. For these megaships, it's as if the Panama Canal was never built. The U.S. began relinquishing control of the canal to Panama in 1979, making this tiny country of only 3 million people a major player in international commerce. And yet, few suspected the true cost. They would soon discover that their golden egg had lost some of its luster. Not only were they losing business to the super cargo ships, but the canal itself had become dangerously run down. Major improvements were needed, and quickly, simply to keep the Panama Canal open.
The Panamanian people play the most important role in our decision making. The canal is extremely important for Panama. So the benefit that any expansion on any program that we put forward has to benefit the people.
Many of the improvements are already underway. 100 more powerful locomotives, each costing $2 million, now guide the ships through the locks. A fleet of stronger, more maneuverable tugs is already escorting vessels, like this 80,000-ton container ship, through the narrowest part of the canal. Communications between ships and canal operators, so vital to safety, have been updated. A global positioning satellite system helps engineers to monitor the movements of many ships in the canal with pinpoint accuracy. And in the near future, an onboard tracking system will become mandatory. But these improvements are the easiest parts of the renovation. Far more difficult ones lie ahead, such as widening the canal where it cuts through Panama's mountainous spine. It is a daunting challenge, both in its scale and in its projected cost, $7 billion. Panamanians could be gambling with the very future of their country. And yet, do they really have a choice? Bulldozers will have to clear-cut thousands of acres of jungle at both ends of the canal. Excavators will need to dig deep into the earth, through thousands of feet of unstable rock and mud. Millions of tons of concrete will have to be poured. But the biggest engineering challenge of all will be building brand new locks next to the current ones. Locks big enough to handle the new megaships. These new locks will need to be 3 times the size of the originals, making them the world's largest.
We are using technology today that back in 1904 didn't exist. And I think that we can solve the engineering problems that we are facing in an engineering way. I think that there are solutions to that.
Yeah, what's the status of South 10 tugboats?
Back on the oil tanker, 2 hours have passed since Dave guided the ship out of the locks and into Gatun Lake. It's a freshwater lake that covers an area 6 times the size of Manhattan. The lake is the great engine that powers the canal. It pumps 55 million gallons of water into the locks to lift and lower each ship through the canal. With up to 40 transits a day, that's 2 billion gallons gone each day that must be replenished. Gatun Lake also provides fresh drinking water for over 1 million Panamanian people. To create the lake, engineers built the Gatun Dam, then the largest in the world, across the Chagres River. It was a remarkable feat of extreme engineering. The lake is replenished by Panama's heavy rains. But there's a problem. Global warming is creating irregular rainy seasons. Low rainfalls cause the water level in the lake to drop, preventing ships from crossing with their full load. They must offload cargo to reduce their draft. Ironically, too much rainfall also causes major problems. Hydraulic engineer Carlos Vargas is responsible for maintaining the canal's water levels.
If we couldn't open the gate and the lakes go too high, the locks itself will be flooded, and the Panama Canal operation will have to be stopped to repair and to release the water and that caused damage to the clients and to the image of the Panama Canal.
Ideally, the water level on the lake should be 85 feet above sea level. Senor Vargas sees that today the level has climbed to a dangerous 87 feet. He calls for immediate action.
Hola, este es Carlos Vargas, manager de hidrología, IP 2204-428, por favor.
Enormous engines inside the dam wall now lift one of the dam's 52-ton steel gates. Within 5 minutes, 20 million gallons of water surge out into the spillway on their way to the sea. And the water level falls to a safe 85 feet. Meanwhile, the oil tanker has made its way across Gatun Lake and is about to enter one of the most treacherous sections of the canal, the Gaylord Cut. This is the narrowest part of the canal, a twisting, turning channel cut through Panama's mountainous spine. This is where Dave's skills get their toughest tests. These mountains were the reason why the canal project almost never happened. The idea seemed so simple. Just dig a ditch 50 miles long by 500 feet wide, and presto, you've connected the Atlantic and the Pacific. But the mountains of Panama were not conquered so easily. They defeated the first attempt. It was the sunny optimism of the early Industrial Revolution that led the great French businessman Ferdinand de Lesseps to tackle the project in 1873. De Lesseps had just come off another engineering triumph, constructing the Suez Canal in Egypt. There, workers had been able to dig a ditch at sea level through the flat Egyptian desert. But Panama presented far more problems than de Lesseps ever imagined. Not only the mountains, but a living threat as well: malaria and yellow fever. At the time, scientists didn't know that these deadly diseases were carried by mosquitoes. Workers died at an alarming rate. After 10 years, the French had finally had enough. By then, 20,000 men were buried in the jungles of Panama, and de Lesseps' business and reputation lay in ruins. Nature had won the first battle, but the war had just begun. The next visionary to take up the cause of a Panama Canal was a real soldier, Theodore Roosevelt. Roosevelt chose John Stevens, a brilliant railway engineer, as the chief of the Panama Canal project in 1905. Stevens had never built a canal before, but he knew how to think big. The first thing he did was to stop all construction work and focus on the health of the workers. Stevens threw all his resources into eradicating yellow fever and malaria from Panama. It worked. In just a year, the fumigation army had eradicated the diseases. Now Stevens could tackle the engineering problems. First on the list was the treacherous Chagres River, which produced killer floods. Rather than fight the river, as de Lesseps had done, Stevens decided to exploit it. He proposed damming up the river where it flowed to the Atlantic to form a lake. Lake Gatun, 85 feet above the oceans. This old film demonstrates his idea. Stevens designed a set of 3 locks on either side of the lake to lift and lower ships over the mountains to reach sea level on the other side.